Today's objective is to be able to solve inequalities with variables on both sides by isolating the variable. However, before we go into those types of inequalities, we're going to just go ahead and review a little bit about what we learned in our previous class of inequalities. So in this example, we have solved the following inequality. 2x plus 3 is greater than 5. We're looking for the values of x that would make this inequality true. And I can look at this inequality and guess different numbers that I can plug in for x that would actually make this work. For example, I can say, well, I think x can be equal to 2, because if I do 2 times 2 plus 3, well, that's 4 plus 3, which gives me 7, and that's definitely bigger than 5, right? So 2, the number 2, works. But I can also say x equal to 3 works, because I can do 2 times 3 plus 3. 2 times 3 is 6 plus 3 is 9, and 9 is definitely bigger than 5, so 3 works as well. I can keep going and I can say x is also can also be equal to 4, because 2 times 4 plus 3 is going to give me 11, and 11 is bigger than 5, so that also works, right? So x can be 2, it can be 3, it can be 4, it can be 5, and the list is going to go on forever. So I can sit here and list all the numbers that are possible solutions for x, but that's probably going to be taking a very long time. So when we say solve an inequality, or a question asks you to solve an inequality, I don't want you to just give me one value of x that's going to work. I want you to give me a little inequality, a shorter inequality that's going to include all these different values of x. So I want you to tell me x can be anything either bigger than a certain number, or smaller than a certain number, or greater than or equal to a certain number, or less than or equal to a certain number. So basically that smaller inequality that we're going to get at the end when we isolate the variable, when we get the variable by itself, it's going to include the 2, it's going to include the 3 and the 4 and the 5 and all the other possible values of x. So make sure that when I ask you to solve an inequality, the first thing that you should be thinking about, I'm not looking for a specific number for x. I'm looking for an inequality, a smaller one, that's going to include every single possible value that I can plug into this inequality that makes it work. So how do we do that? How do we get a shorter inequality that's going to give us all the values that x could be? So the way we do that is by taking our inequality and isolating our variables so that we can have an inequality that includes all of our possible solutions. So if we have 2x plus 3 is greater than 5, we want to figure out how do we get this x by itself and everything else to the opposite side. Now if this were an equal sign instead of an inequality sign, so if we had 2x plus 3 is equal to 5, we want to think about what we want to move to the other side so that our couple is left by itself. In this case, we want to move the 3 away from our couple so that the couple doesn't have anything on the same side of it. And so we're going to subtract 3 on both sides in order to get the couple by itself. Well, in the inequality, we would do the exact same thing. We're going to subtract this 3 on both sides. Now, when you're doing your work, you don't have to do this piece that I'm doing in red, where I'm showing you how it works with the equation. I'm just using it so that you guys can see the relationship between how we solve an equation as compared to how we solve an inequality. And you'll see that it's the exact same process. And so we get 2x is greater than positive 2, which is the same thing that we would have gotten here if it was an equation instead. Now that my couple is by itself, now I can go ahead and divorce my couple and get rid of this positive 2 so that we just have x on one side. Now I know that 2x is the same thing as 2 times x, so if I want to get rid of that 2, I'm going to use my inverse operation and divide by 2 on both sides. And again, nothing about what we do changes if we have an inequality sign instead. We're going to do the same exact thing and divorce our couple by dividing by the coefficient. And we get x is greater than positive 1, which is the same thing that we would get on this side if it were an equation instead. So this little inequality that we got here, this is telling me x could be anything greater than positive 1. So it can be 2, it can be 3, it can be 4, which is the exact same thing that we found out earlier before when we tried different numbers. We saw that anything that was either a 2, 3, 4, so anything that was bigger than 1, gave us something that gave us a true statement. So now this little inequality includes all of these numbers, all of those numbers that we tested before. It includes the 2, it includes the 3, the 4, the 5, and any other number that is bigger than 1. So instead of listing all of those numbers, we use the smaller inequality to include all of them. Whereas in our equation, this is telling me x can only be exactly 1. It cannot be anything else. But in our inequality, it can have multiple different values. So now that we've reviewed a two-step inequality, let's look at an inequality that has now variables on both sides. We already learned how to solve equations that have variables on both sides in our previous lessons. So we're going to apply the same concepts and ideas and the same skills when we are solving an inequality that looks like this. So again, if I'm solving an inequality, I'm looking for a shorter inequality that would include all possible solutions for this bigger inequality here. And in order for me to do that, that means that I have to isolate this variable. I got to get x by itself so that I get the shorter inequality that includes every possible solution that I can get for this. So what we're going to do is, again, we're going to follow the same steps as if we were an equal sign. So if I had 7x minus 8 is equal to 4x plus 10, the first thing that we always start with, or the first thing that we usually want to do, is make sure that our couples are on one side of the equation, right? Or we want to make sure that our variables are on one side of the equation. So we either want to move the 4x to the 7x or the 7x to the 4x. And in previous lesson, I told you, well, it doesn't really matter, right? In equations, you can start anywhere. You can kind of go your own route as long as you're using your inverse operations to move from one side of your equal sign to the other. In inequalities, the same thing is true. You can start pretty much moving either or of the variables. However, if you move the little one to the bigger one, you will always avoid your negative signs. And remember that negative signs are very important when we're solving inequalities. So what I would suggest for inequalities is to always start by moving the smaller variable to the bigger one. That way you will avoid having a negative couple, and that way when you divorce your couple at the end, you won't have to switch the sign. Because remember, if I divorce my couple and I do that by dividing by a negative number in my inequality, then I must always switch the inequality sign to the opposite direction. But if my couple is always positive, then I don't really have to worry about that. So my number one suggestion is to always start by bringing the smaller variable to the biggest one. So in this case, I'm going to bring the 4x to the 7x. And if it were an equation, again, we will use our inverse operation. This is positive, so I would subtract 4x from both sides. And in our inequality, we're going to do the exact same thing. So we're going to subtract 4x here, and we're going to subtract 4x over here as well. And so that's going to give me 3x minus 8 is greater than or equal to positive 10, because this is going to cancel out. And that's the exact same thing that we get on the other side if it were an equation. And again, you don't have to do what I'm doing in red in your work. This is just a way of me showing you that nothing about what we do when we're solving an inequality changes as compared to when we're solving an equation. And a lot of you guys are pros at solving these equations. So don't let the inequality sign throw you off. And so now we have a two-step inequality here that's very similar to the one that we just solved in the previous example. And now I have to ask myself, what do I want to move around in order to get my couple by itself? Do I want to move the negative 8 or do I want to move the positive 10? Well, if my goal is to get the couple by itself right now, I have to move that negative 8 to the opposite side. If it was an equation, I would use my inverse operation one more time and I would add 8. And so we're going to do the exact same thing here on our inequality. We're going to add 8 on this side and we're going to get 3x is greater than or equal to 18. And we would get the same exact thing on this side. Okay, so now I have my couple by itself. Everything else is on the other side. I send the negative 8 to the other side. And now I have to divorce my couple. So again, if I have a couple, that means this couple is being multiplied. I have 3 times x. And so if I want to get rid of this 3, Well, then my job here is to use the inverse operation and divide by 3 on both sides. So this is why bringing the smaller variable to the bigger one is important, because if I would have gotten to this step and what I'm dividing by is negative, then I would have to flip the sign at the end, which is very easy to forget. But if we bring the little variable to the bigger one, we are most likely always going to end up with a positive couple. Okay, and so when I divide by 3, I'm going to get 1x is greater than or equal to positive 6, which is again the same exact thing I would have gotten here if it were an equation. But in this equation, the solution is x is equal to 6. That means x can only be equal to 6 in this equation that I have in red over here. However, if I'm looking at the inequality here that I have in black, this is telling me x can be equal to 6, but it could also be anything bigger than that. It could be any other number that is greater than 6. So this shorter inequality gave us every possible solution that I can substitute into this inequality here that we began with and give me a true statement. So let's try one of these out and see that we've actually answered we've actually solved our inequality correctly. If x is greater than or equal to 6, again, it means I can pick any number that is either equal to 6 or greater than 6, and it would work for my inequality. So I'm going to pick the number 8. And I'm going to plug it into both sides of my inequality. So I have 7 parentheses 8 minus 8. And I'm saying that if x is equal to 8, this is going to give me something greater than or equal to 4 times 8 plus 10. And we're going to check if that's true. When I put this into my calculator, this is going to give me 48. And when I plug this into my calculator, this is going to give me 42. And so I want to check if the inequality fits that. Is 48 greater than or equal to 42? And it is. Okay? It either has to be bigger or equal to it. It does not have to be both. It will only be one or the two. And 48 is definitely greater than 42, so that number worked. And if I check any other number that is greater than or equal to 6, you will see that it would also work. Notice that when we're checking for inequalities that have variables on both sides, we're not checking that both sides are equal, just like we would in an equation. Right here, if I'm checking here, I would have to get same thing on the both sides. We're checking to see that what we get when we simplify both sides fits the inequality. So in this case, when I simplified over here and when I simplified over here, I got 48 is greater than or equal to 42, which is definitely true.